Good morning, everyone, and again, welcome to the IPLSC feedback webinar. I'm Rebecca Turner, and I have been the principal examiner for both the summer and winter series for the primary level qualification since 2015. I've been marking on the JSC suite of qualifications for about 17 years, and I've been an examiner for over 25 years and have taught both primary and secondary students. A quick look at the agenda for today. So we're going to look at the very rigorous marking and writing procedure for all the qualifications, look at the examiner feedback report, which I'm hoping that you will be familiar with, look at areas of good achievement for the candidates and the areas that they tend to be a bit weaker in, have a go at teacher actions to achieve the next level, and then a short question and answer session. So in terms of preparing the exam, as I said, it's a very long and rigorous process with many checks on the papers produced to make sure that they are similar year on year by covering the full extent of the specification with questions targeted at different levels of achievement, the different subject areas, the assessment objectives, the 5 assessment objectives, and to ensure parity between the years. So a first draft of the paper is prepared, which then goes to the chair who oversees all of the JSC papers. And then a second draft is prepared. We then spend 2 days in the question paper evaluation committee, fully dissecting questions in terms of the distractors used in multiple choice questions and the language used, as we are aware that some candidates or many candidates may have English as a second language. It gets passed to a proofreader and it's reviewed by several other experienced examiners who make any comments, and we make changes based on that. Once the paper's gone live and the candidates have sat it, they start to be uploaded, and all the examiners review the live scripts, looking for answers that may not be on the mark scheme, but which are an acceptable scientific answer. So this may be at a higher level, or candidates may be using more simplistic language to try and express themselves. So we decide where that boundary lay in terms of candidates' responses. The mark scheme is then revised by myself, and myself and the team leader then start to apply this mark scheme to live scripts for selecting seeds, training questions, and the test questions for the other examiners. A new mark scheme is then sent to the examiners. They have practice questions or training questions that they go through where we have explanations as to why we've given them the marks we have, and they mark 10 test questions. They have to get at least 8 out of 10 for each question that they're marking on correct. If they get less than that, they will be given detailed feedback and explanation, and then they will have another set of 10. If they don't pass that, then they are stopped from marking on that question. The vast majority of examiners on the vast majority of questions achieve 10 out of 10, so there is no problem there. All feedback will be given by myself or team leaders to them on any marking that they're doing. So then a small number of live scripts are marked, and myself and the team leader again do spot checks on the first of 10 scripts in the first batch that they've marked. And again, any feedback is given if there's any difference to what we would have given. The seeds appear regularly for examiners. They can look up how they're doing on their own seeds. And again, these are reviewed by myself or the team leader. Other spot checks are done throughout the marking process. And finally, candidates who are close to grade boundaries do have their scripts reviewed, and any questions where there is doubt are passed back to me for checking to see if they have actually achieved the next grade up. So moving on to the Principal Examiner's Report, which I hope you're familiar with. This is produced for each exam series and can be found on the Pearson website. It outlines general comments on candidates' performance and looks at each question in more detail and provides a summary of how candidates could achieve more as they go forward. So this is an example from the summer one, the general comments at the start of the report, so outlining what the P3 candidates did well and looking at P2 candidates and how they have developed recently, and how those who are borderline on P3 could maybe focus on a particular area. So quite often it's the fair testing, reliability and accuracy of investigations that need further development. And then feedback for an individual question. So this is just one example to show where candidates had achieved well. So P2 and P3 had achieved both the marks available, and P1 had often got 1 mark, and outlining where they had got that. So for some candidates, some P1 candidates had named them the incorrect way round, but students using the correct terminology, although some used up thrust and friction, which were both acceptable answers, but some just said an up force and a down force. So that was for the skydiver coming out of the plane with some forces shown on him, and they were asked to name 2 of those forces. Going on then, the end of the examiner's report will look at areas for improving their understanding. So based on the questions of that particular year, so last June, they weren't too sure about germination and growth of plants, or the difference between germination and growth, that plant reproduction structures was not quite where it needed to be, and a little bit of feedback for P1 standard candidates who may benefit from further support during their practical work to help understand how concepts transfer to new investigations. So this is an area, again, P1 candidates really struggle with section B in terms of taking what they know about investigations and putting it into a new situation. So looking at section A, I'm sure you're very familiar with this, multiple choice and short answer questions. There are 45 marks, of which 20 are biology, 15 are physics, and 10 are chemistry. That's due to the amount of content in the year 6 specification, so that it reflects overall how much time they've spent on the biology, physics, and chemistry areas of the specification. It tests most often the knowledge of scientific ideas, which is basic recall, understanding scientific ideas. So they may need to try and link a couple of ideas together, and applying scientific ideas. So they may be given a novel or new situation, and they need to apply what they know about that particular topic to the question. So a quick look at areas of high achievement by candidates. As you will see, it's color-coded by year group content as well. So they generally do pretty well on the year 3 and the year 4 content, but struggle a bit more with the year 5 and 6 content, perhaps because there's greater language demand being put on them. So the sorts of questions they did well on was identifying the parts of a plant, identifying the leaf, which organ pumps blood around the body as the heart, constructing a food chain. So with this one, the candidates who didn't achieve marks on this one had quite often misunderstood the meaning of the arrows. So some of them had actually put a complete reverse food chain. So they started with lettuce over on the right and worked their way over, which demonstrates a misunderstanding of what the arrows show. And a lot of internet sites sadly have arrows going in the incorrect direction. So they do need to understand that it shows the flow of energy going from one organism to the next. So it always goes up the food chain. A few candidates they had correctly written lettuce, snail, frog, and snake, but they had added the information on the right-hand side of the table in beneath it, which was not marked incorrectly. They had got the organisms correct, but they're just wasting a little bit of time. So it comes down again to trying to ensure they've read the question and understand what they need to do. The key, again, they generally answered very well and were able to follow through the questions and come up with the correct answers to discover which invertebrate it was in the diagram. This one, we'll be looking in a little bit about the germination question that was on this summer's paper as well. So they were just asked about a growing plant and what conditions are needed for a plant to grow well. So we were looking for light and water, which most candidates achieved well on. And so we'll mention this question again when we come back to the germination one. The air in the atmosphere composed of the gases. Again, most of them did know the three named gases, oxygen, nitrogen, and carbon dioxide there. Features of different vertebrates, again, seem to be quite well known, with a lot of them achieving B backbone, have dry scales, and are cold-blooded, although some may well have put C, living in water, cold-blooded, have soft and damp skin, but of course soft and damp skin is related to the amphibians. So looking at the physics area now, so again the year 3 areas are highlighted as having been done well, and some of the year 4 content, they did quite well on the year 6 content as well in this particular subject area. So why is the room dark? Absence of light. Objects that are sources of light, again, they're generally quite good on that now. The units or the symbol for the unit of force as newtons, they were aware of that. And going on then to the circuit diagram, I was actually very pleased with the candidates here. I thought this might have thrown them, but a lot of them did understand that a motor was needed in order to run the fan, and they correctly circled, they correctly indicated C was the correct circuit diagram for it. The planets, they needed to draw one line from each planet to the approximate surface temperature, and they were told that the further from the sun they are, the cooler their surface temperature. So large numbers of candidates did get this one correct. They generally got the Earth correct, although some candidates did put plus 500 for Earth. The ones for Mars and Venus were sometimes mixed up, however. So again, it's reading the information, encouraging the candidates to read the information carefully, think about what they know, and then apply their reasoning to it. And then the streamlined object travelling through water was again done very well, although occasionally candidates only ticked one box. So again, they do need to read carefully what the instructions are for them to do. In terms of chemistry, there isn't any year 3 content for us to test, so that's just to the year 4, 5, and 6 content. So looking at materials that can behave like a liquid is a heap of sand, so very fine. Particles of solids can act as a liquid. Reversible and irreversible changes. Again, they were generally able to say that bread cooking and wood burning were 2 examples of irreversible changes. So they just need to be familiar with the idea that boiling, melting are just changes of state which are reversible, as opposed to the irreversible actions of cooking and wood burning. Again, choosing the correct words here was done pretty well, although a few candidates did put in cooking in the first one. Separating substances is again a fairly important part of the candidate's knowledge for the chemistry section, and they were able to identify that as sieving, which is a fairly straightforward one for them to get. And looking at the amount of water in a glass before and after it's left in a warm room, that we're testing their understanding of the names of the changes of state, and the majority of candidates did indeed again get that one correct. When we come to the scientific inquiry, candidates often do a bit more poorly on this section than they do on the section A. What they did well in the summer was to plan simple scientific inquiries, so ordering the steps that they were given. They were mixed up and they needed to put them in the correct order. A small number of candidates omitted one of the boxes. They didn't fill up all the boxes, and a few candidates put W into it from the step D, pouring acid W into bicarbonate of soda. So not quite understanding fully what was required of them. So maybe spending a little bit of time with P1 level candidates to try and do this sort of activity independently. The second investigation was about putting a ball into different temperatures, basically, but that was a little jump that the candidates needed to make based on the information given. And then they were just asked to name the piece of equipment used to measure in step 3 and 5, and the majority of candidates could correctly answer a ruler or a measuring tape for that one. And then for the choice chamber investigation, where some water was added to the tissue paper for the wood lice to make it damp, they were asked just to measure the volume there. Again, that was quite a straightforward question. There were no other increments put onto the scale that they were expected to read, so they did pretty well on that. If we go on then to look at the slightly more challenging questions, these are divided into either moderate or difficult. With the moderate ones, candidates may have achieved 1 out of 2 marks, or P1s and lower P2s would have had more difficulty in answering it. So if we have a little look, first of all, at question 15, this is an understanding type question. So they needed to take information from 2 different areas of the specification and apply to a change of state, because a liquid was changing into a gas there. So they had to recognise that it was a change of state and that a new substance is formed, which is why perhaps some of the P1 candidates struggled with that in terms of a new substance being formed. Question 17 is a direct recall, so it's just a knowledge question from the specification, and they were expected to know ventilation is linked with breathing. Ventilation is quite a tricky word that, again, the P1 candidates may find difficult to understand. And then they've got to link it to the correct part of the respiratory system, of the respiratory actions, rather. So you might want to come up with a little mnemonic to try and encourage candidates to remember this. So a little one that I just came up with was bat vets rarely occur. So linking the B and the V with the R and the O, so that they could maybe try and remember that breathing is linked with ventilation and respiration is to do with oxygen. So using little tricks like that may help candidates remember some of these points. This graph question, candidates found a bit more challenging, with many candidates achieving 1 mark and generally the P3 candidates achieving both. So the candidates needed to look in isolation at each line of the graph and try and decide which conclusion could be drawn for each line. So for A, as the temperature increased, the mass decreased. And for B, it was a little bit of an odd one. It goes up and goes down. And then for C, what they would perhaps be more familiar with in terms of investigating sugar for themselves, which is as the temperature increased, the mass increased as well. I think perhaps some of the P1 candidates were just put off by the graph and didn't really approach it logically, thinking about 1 line at a time. Few candidates drew more than 1 line from the substance, and more candidates got line A correct than B and C. So this one about germination, as I mentioned before, comparing that to the general growth of the plants. So it's a bit of a misconception that some candidates have that germination and growth are 2 slightly different things. And again, where actually doing some little investigations can help with the candidate's understanding of this. So doing the investigation where you have some seeds in the dark and some seeds in the light, making sure they're at the same temperature, of course, and seeing that they both germinate perfectly well. It's the consequent growth that is affected by the lack of light. So a lot of candidates had put down light, which is why this was a few candidates got it correct, which is why it's considered a difficult one. But quite a few candidates still put down water. So although sometimes we might provide information in a question stem that they can use, we had said state 1 other condition required. So the word other there was quite important for them to realise that rewriting water would not be a correct answer. So we were really looking for either temperature or oxygen, but we felt that warmth and air were acceptable alternatives at this level of their scientific education. Going on then to look at this sort of question, which we quite often have, but which a lot of candidates find more challenging. It is an explain question and it is 2 marks. So we're always going to be looking for 2 things that are linked together. So with this question, strong P3 candidates managed to achieve both marks, and many candidates did achieve 1 mark for the idea of increased grip or increased friction. A small number of candidates did suggest that the spikes actually reduced friction. So the idea that the grip is improved on the running surface and stops the athlete slipping. Quite a few candidates did suggest it was to stop the athlete falling over, but we felt that was just a bit too vague for the candidates to be able to get the mark there. So it does need to try and be linked to their scientific knowledge and understanding, and the idea of the improved grip increasing friction. When we have a look at the diagram showing a flower being visited by an insect, so they've got a little bit of a visual stimulus to try and help them remember the information about flowering plants. And we're looking for 2 features of a flower that make it suitable for insect pollination. So again, quite a few candidates did manage to get 1 mark for this, but they didn't always demonstrate a deeper level of understanding. So accepting anything about coloured or bright petals. A significant number of candidates did say large petals. So again, maybe having flowers of different sizes. So, and pointing out that small insects may visit smaller flowers with smaller petals and so on. And we were accepting the scent or the perfume, what the stigma is like, or the pollen. And we do accept nectar. Although nectar isn't on the specification, we're more than happy to accept that as it would be a correct answer. That's something that the insects go to collect. Part B was asking about wind pollination. So they didn't have the stimulus of a diagram on this one, but they were asked for 1 feature of a flower, making it suitable for wind pollination. And candidates didn't do terribly well on this question, with many giving another feature of an insect pollinated plant instead. Again, this question is quite nice if you have been able to do the investigation or little test with the candidates. Certainly when I was teaching primary, I would also take them outside for PE. So I would try to link this to a PE lesson, have candidates take their pulse sitting at their desk before they got changed and went outside, finding their pulse after exercise, which quite often is a lot easier for them to do so, and then taking it again once they've sat back down again. So we were looking here for that the pulse rate decreases to the normal pulse rate. And this is an application type question. So it's taking what they know about the heart rate during exercise and applying it to their pulse rate and to a situation that they are given that they are not directly expected to know about. So again, doing the practical work is very important for the low ability candidates, because it's a concrete activity that they've seen and felt for themselves. So that helps to embed it for them. Now, this question was very interesting, a lot, and demonstrated quite well the importance of reading a question really carefully before they answer it. They looked at the diagram, saw organ 1 and organ 2, and read the first 3 words of the question, give the name, and they wrote down organ 1 equals lungs, organ 2 equals heart, and moved on to the next question. Rather than reading, give the name of the region in the body where the organs are found, which we were looking for thorax in this one. So it was only about 50% of the candidates answered this correctly, and very few of those actually named it the thorax. It's one of those words that is quite tricky, again, especially for candidates for whom English is a second language. So we did accept chest, even though ideally we're looking for thorax, and it's something to try and work on, certainly with your P3 candidates and possibly some of your higher achieving P2 candidates, to try and use the correct term there. So we did also consider, because a lot of candidates put ribs or rib cage. but we didn't accept that because that's part of the skeletal system. So it's not really an area of the human body, a region of the human body. But we did feel that candidates who had put inside the ribs was just about acceptable. So that was the lowest level that we would accept on this type of question. Going on to look at the cross-section of a carpel in a flowering plant. So again, a link that the candidates needed to make for themselves was realising or recognising that a carpel was the female part of the plant. And some candidates hadn't done that with what they named part X, giving it the name of a filament. So they had confused the carpel with the stamen. Quite a few candidates put stigma, probably because it's the first one they come to of the three. Stigma, style and ovary, and some had put that it was the pollen tube, which we didn't give the mark for, but did show that they understood that the pollen tube grows down through this area to try and reach the ovary. For part B, many stated seeds, which was a given the mark. So asked what was produced in there. We were really ideally looking for the idea of ovules or ova, but after fertilization, the seeds are produced there. So that was fine to suggest that. But we didn't accept ovary, eggs, pollen, or fruit, which were common errors that they made. So understanding that the ovules become the seeds held within the fruit is quite important. So we were pointing there at the individual ova. The next question, the students were asked to give an approximate value for the distance of Neptune from the Sun. So it's relying on their knowledge of the order of the planets so that they would know that Neptune is further away. We did have quite a long discussion about what to accept here. So we didn't feel that the unit kilometres was necessary, but we felt that part of the value was the million. So they did need to put any value over 2,900 million. The kilometres, if they hadn't put kilometres, we didn't penalise them. Some candidates just put down 3,000, which was not quite enough for it. So do encourage candidates to think carefully about what their answers are saying and ensure that the values that they give are relevant. Then the seed, this is being dispersed by animals. And it says that they've the spines with small hooks, again, to try and give them a visual stimulus so that they may think about the seed being attached to the animal and then being carried to a new area. Quite a number of candidates did say they hold them in their mouth and go to a new area and spit them out, which is more the sort of things that they are eating. So if they're eating fruits and so on, then that may occur. But with this one, it is only that they are attached to the animal's fur. And so quite a lot of candidates did achieve that first mark, but they didn't get the second mark for moving to another area. They might just say it's attached to the animal's fur and then it falls off. So they didn't go that extra little step to say the animal moves to a new area and then the seed drops off, or the seed falls into a new area where it could then germinate and extend its area of growth. So coming on then to section B, the scientific inquiry. There's 15 marks here, and a lot of these are looking at analysing and interpreting information and data, and to evaluate, make judgments, and draw conclusions. And as I said earlier, this is an area that candidates find a lot harder to achieve on, and most candidates achieve less well on this section than they do on section A, which is again why it's really important to try and do as much of the practical work as you can. I appreciate that some primary schools don't always have much in the way of equipment, but using photographs, images, or trying to find some of these type of investigations done on the internet so that they can see a little video of it and understand what was carried out. Some investigations are quite easy to do within the primary situation without too much equipment. Things like the helicopter with different numbers of paper clips on, or the measuring the heart rate of people, of the students as they're doing exercise. And you could look at the effect of different levels of exercise on that as well. So the first investigation that they had was about adding acid to bicarbonate of soda and adding different acids. So again, just using lemon juice or vinegar should work with this if you've not got much equipment or chemicals associated with your school. I wouldn't expect you to have terribly many acids lurking around at a primary school. So they were given, as we looked at before, they were given the steps mixed up, and a lot of candidates were able to do that, order them correctly. They were then asked to give a reason why the same volume of each acid should be used. And this is one of the areas that I think really does need a little bit more attention paid to it, perhaps, to try and help candidates pick these things apart, because an awful lot of candidates do write down fair test, but then they also add in things such as accuracy or reliability, which then negates the mark that they have just achieved, which is a bit of a shame. So anything where we're asking them about the same, things being kept the same, should have the response of to make it a fair test, and encourage your candidates to put a full stop after that and not add anything further. There are other things as we go through this presentation that I will suggest to areas where you could consider accuracy and reliability a bit more. Some candidates, higher level achieving candidates, may have said it's a control variable or it is controlled, which were perfectly acceptable answers as well. So P1 and P2 candidates particularly need to try and develop a better understanding of these terms. Candidates often take this error or lack of understanding through to higher levels of their scientific education. So if incorrectly, and it's very hard to then try and get them to fully understand it. So trying to nail it at an early level is really worthwhile. So in part C, they had the students' results, and each set of results was repeated 3 times. And we've got the height of the foam in there. Again, and they were asked to explain why the student does 3 tests for each acid. So again, we're looking here for the idea of reliability, which many P2 and P3 candidates did achieve. Some, again, would also add accuracy, so losing the mark. You could talk to the candidates about accuracy using this, and you could add maybe on acid W, make that 1.45, 1.32, 1.59. So indicating that the height was measured to a greater degree of accuracy, which would probably be unlikely, because 1.4 centimeters, you're already reading to millimeters there. Going down to tenths of millimeters would be very difficult to try and ascertain, but it gives an indication of what the accuracy means. So the repeating the tests is the reliability. So some candidates would say for the second mark point to get the correct result, which there isn't really a correct result. It's the result that you get, and looking to see if they are very similar to each other in order to say, yeah, those 3 tests were all done well. We didn't make any mistakes in them. But some candidates said to check the results, which we felt was just about sufficient for the second mark point. So they would say to check the results were similar. The next investigation, again, was the tennis ball in the different temperatures. And the first question I've got illustrated here, because we looked at the first question earlier. State one thing the student does with the ball to be sure they make systematic and careful observations. Now, this is a really, really hard question for candidates. There's only ever a small number of fairly high achieving P3 candidates who usually get this right. So they need to look. Sometimes there is information given in the steps to try and help them. So in this case, it was to hold the bottom of the ball 100 centimeters above the ground. So it's a particular part of the apparatus held in a certain position, and to make sure that's always the same. So if they were doing a car down a ramp, that the front of the car maybe would always be held in the same position. You might have a mark on the ramp in order to show where the front of the car should be held before being released. So we're looking for something that is always got to be done exactly the same and has to be very carefully set up for that. Let's say it is a very difficult area for candidates. They were then given a set of results, and they were asked, what conclusion can the student make from this? And it's been very pleasing, actually, to see that candidates' ability to write a conclusion has improved greatly over the last 3 or 4 years. So candidates need to understand that really when they're answering this kind of question, they need to express themselves in terms of comparatives, so hotter, higher, or superlatives, so the hottest ball bounced highest. Either of those are acceptable to gain the 2 marks there. And most P2 and P3 candidates were able to score either 1 or 2 marks. So if they hadn't got the hotter, the higher, if they said the hot ball bounces the highest, they would get 1 mark for that. So it wasn't linking the temperature with the different heights, but they had made an attempt at writing a comparative. It was also very pleasing to see that some P1 candidates were making basic statements, such as it bounced high in the sun, which wasn't quite enough for the mark, but it is going in the right direction for them. If they had said the hot ball bounced high in the sun, the cold ball bounced low, then they would have gotten 2 marks because they have made simple comparisons. So for your low ability candidates who may have problems with comparatives or superlatives in their answers, picking out to this happened on this one, that happened on the other one, they may still be able to get a single mark out of it if it's comparing the 2 of them. But as I say, it's been very pleasing to see that this has improved dramatically with the candidates. Going on then to the third investigation, which was the choice chamber investigation. They were given a set of results with number of woodlice in the wet half and number of woodlice in the dry half. And they're given a conclusion. So the student concludes woodlice prefer a wet environment, and they were asked how the results supported that conclusion. So it was a very interesting question to look at again in terms of how the students answered it. Some strong P3 candidates noted that the results were the same in both halves, and so would say that, and go on to say 12 woodlice were found in the wet half of the dish, but only 3 were found in the dry halves of the dishes, in all of the dishes. And some of them went further to write a ratio of 12 to 3, or even simplifying it to 4 to 1 wet to dry. So I felt that was quite impressive for those candidates starting to think about how they could present their data mathematically in the best way. So that was really, really good to see. Many other candidates would just reuse words from the stem and say things like the woodlice preferred the wet side, which was not using the information in the table. They didn't add anything to it. They didn't say 12 woodlice were found in the wet environment and only 3 in the dry environment, which would have got them something. Some candidates said all woodlice preferred the wet side, which again is not the case based on the results. So you need to encourage candidates to look carefully at each row and what the conclusion was and whether each row supports that conclusion. So P1s and P2s found it quite difficult to score here, with some of the P2s achieving 1 mark. We then asked about a safety precaution that the student should take after handling the woodlice. And again, this is something that possibly you could work a little bit more with your P1 candidates with, because quite often candidates will just give wear goggles, safety precaution, wear goggles, and that's what they put down, or wear a lab coat or tie your hair back. But they need to try and think a little bit more now about the investigation that's being done. Are the woodlice likely to be a danger to your eyes? Not really. If they had very long hair, possibly the hair could get in contact with the woodlice, which would not be advisable. But really, we're looking for washing hands or washing the surfaces. These are organisms that may carry bacteria or germs or bugs or any other way you want to call it on their bodies. And so washing hands is going to be quite important there. So trying to encourage candidates to think about what the big safety worry is on a particular investigation. And that's more so, as I say, the P1 grade candidates that might need a little bit more help and support on that. Going on to D, I was quite surprised with this one because this was registered as a difficult question for candidates. And I think the main reason for that was that they needed to tick yes for all three of them. And candidates were quite reluctant to do that, with some of them crossing out one of the yeses and putting a tick on the other side when they put 3 ticks in. So have the courage of their convictions and put down what they think would be the correct answer for it. So going on now to have a little look at how candidates could improve their grades or improve their marks. In general, try to ensure that candidates read the whole question before answering and maybe highlight the key words in the question. So as they're thinking about their answer, before they write it down, they can have another little quick look and make sure that they have answered what is being asked and not a different question. So, and that's across the board. There were situations, particularly with the lungs and heart being in the thorax, that all grades of candidates made that error. So it's something to try and drive home to candidates, and we'll carry them through into higher levels of exams across the board, to be honest, not just in science. So areas for development of P1 candidates: being able to draw bar graphs accurately. Now, a lot of these candidates do this quite well, but maybe needing to encourage them to use a ruler. So in the little diagram I've got in there, the one on the left, you cannot actually tell what the top value is trying to record. And this is what we see in some of the weaker ones where we can't give them the mark for drawing it accurately. If they can at least draw the top line with a ruler, that would be great. But if they've got their ruler out, then they should really be drawing the sides of it with a ruler as well. It's bringing some of their mathematical skills into the science lab. And some candidates might be reluctant to do that. And while they may use a ruler beautifully in maths, they then don't in science. So please do encourage them to try and draw nice and neat. And it's quite often, again, some candidates will try to draw in pen and then realise they've made a mistake and try to cross it out. So using pencil and having a rubber so that if they've made an error, they can rub it out and put it in the correct place, make it the correct height. Also being able to label their axes and include units. So quite often there may be a results table, which may or may not have the length included, the units for the length included. So we may be expecting the candidates to be able to recognise when it's appropriate to measure in millimetres or centimetres or metres. Developing the basic scientific vocabulary for P1 candidates. So trying to look at things like precipitation, evaporation, condensation. So things that they may already be aware of: steamed up windows, it's raining, the water's disappeared. Trying to get those words embedded in this level of candidate. Things like solute, solvent, and solution are quite tricky words, and they sound very similar. So maybe not trying to bash those home as much, but just trying to get this basic vocabulary so that when they get these lower level questions, they can make sure they nail them. Knowing the names of different pieces of equipment. So knowing measuring cylinder or beaker. And again, this could be somewhere where you could bring in the ideas of accuracy. So if you were looking at measuring a particular volume of a liquid for an investigation, which is it better to measure it in? Well, measuring it in a beaker, you might be able to measure 100 cubic centimeters because it's got quite a thick bar showing 100 centimeters, but it's not very accurate. You might only have 95 centimeters in that beaker, or you might have 105 centimeters. So then it's not really making the test a fair test, because you could have varying volumes. Whereas in a measuring cylinder, you've got really nice small units in between that you can measure very, very accurately with. Knowing the different units of measurement, so temperature, time, volume, length, mass, and forces, is always quite worthwhile, so that they have got that as a basic tenet that they can then use in their science investigations. And identifying a specific safety action for an investigation. So, as I say, trying to focus in on what the investigation is asking candidates to do so that they are focused on it. Developing P2 candidates. So these candidates really need to be able to draw line graphs. So trying to encourage them to do nice, neat little X's over the point where they need to plot it, and then trying to draw lines of best fit. That's quite a high level activity, drawing a line of best fit well, but we do give quite a degree of latitude in that when they're drawing them, but again, bringing their maths into their science level. Be able to read scales between major lines. So if we look at the two examples that I've got on the screen, we've got one that goes up in ones and one that goes up in hundreds. The one that goes up in ones has 5 increments. So therefore each one must be worth 0.2. With the one that goes up in hundreds, we've only got 4 increments. So the middle one has to be 50 and each of the others 25. And again, you could use an activity such as this to ask them which type of scale would you use to measure, say, 7 grams on, whilst you would be able to be quite accurate with the one on the left. The one on the right, it would be a big estimate as to where that would be, because you know where 0 is, you know where 25 is. Trying to work out where exactly 7 would be really difficult. So again, this is about the accuracy idea. Starting to develop more advanced scientific vocabulary. So things like solute, solvent, and solution, knowing very well what the difference between those is. Thorax, again, it's a tricky word, but your higher P2 should be able to understand that and take that forward. And the term variable, so something that's changing in the investigation or being kept the same. And then developing a greater understanding of the differences between fair tests, reliability, and accuracy, so they can nail those well. P3 candidates, or maybe high-level P2s looking to achieve P3, they're already achieving very well. They've got a lot of knowledge and can apply it, and they're familiar with a lot of the practical investigations and can adapt what they know about investigations to a new situation. So learning to plot points on a scatter graph and eventually be able to draw a line of best fit through that. It's not something we ask very often, but that's not to say it won't appear one day. Being able to identify evidence to support a conclusion. So looking at what features do support it, and say they did pretty well nail this, the P3 candidates on the woodlice investigations. They did do very well on that. Continue to develop an understanding of which variables need to be controlled and which will be changed. So this is something that will support them very much going into their secondary science education, is being able to understand the variables, controlled variables, changed variables, and what's being measured. And the one that, as I said, everybody finds difficult, developing an understanding of taking systematic and careful observations. Okay, so that's my presentation. So we've now got a little bit of